myself Anna Sahib Gorane from RBNB College Srirampur. In last lecture we have solved some numericals based on the chapter Electromagnetic Induction from 12th Science. Today we also see some numericals based on the same topic. An aircraft of wingspan of 50 meter flies horizontally in Earth's magnetic field, flies horizontally in Earth's magnetic field. Earth's magnetic field of 6 into 10 raised to minus 5 Tesla. This is the magnetic induction, 6 into 10 raised to minus 5 Tesla at a speed of 400 meter per second. Calculate EMF generated between tips of wings of aircraft. In this problem, the given data is aircraft of wingspan of 50 meter, that is the length of that wings is 50 meter. Horizontally in Earth's magnetic field, that is induction B, 6 multiplied by 10 raised to minus 5 Tesla, and V is given, that is 400 meter per second. BLV, these are our given data, and we have to find the EMF induced, that is E. We use the simple formula, E is equal to BLV. Formula carries half mark, you know. B, that is 6 into 10 raised to minus 5. L, that is 50 meter. V, that is 400. Now see here, 4 into 5 is 20, 20 into 6 is 120, and 1, 2, 3 into 10 raised to minus 5. So this is 1.2 into 10 raised to 5 multiplied by 10 raised to minus 5 plus 5 minus 5, that is 10 raised to 0, and we know it is 1. So this EMF is 1.2 volt. Our answer is EMF is 1.2 volt. Very simple problem. It carries 2 marks. Then we see next numerical based on the same topic. Theory part you know. Using that theory part we write the formulae. You know some formulae. By writing the proper formulae we can easily solve the numericals. Calculate the value of induced EMF between the ends of an axle of railway engine carriage (1.75 meter) long, traveling on level ground. With uniform velocity of 50 km per hour. Velocity is given in kilometer per hour. The vertical component of Earth's magnetic field we call it as BV. And that value is given, and it is 5 into 10 raised to minus 5 Tesla. We have to find the induced EMF between the ends of the axle. Now here L is 1.75 meter given. Firstly see our given data. L is 1.75 meter. Speed is 50 km per hour. That is 51 km means 1000 meter. 1 hour means 3600 seconds. This is in meter per second. That is 50 into by solving this is 5 upon 80. 5 upon 18 meter per second. 50 into 5 upon 18. This is converted into, and this BV is, that is B is 5 into 10 raised to minus 5 Tesla. That is Weber per meter square. B is given. Again here our formula is E is equal to BLV, 5 into 10 raised to minus 5, L is 50, sorry, L is 1.75, and this V is 50 into 5 by 18. See here, this 50 into 5, 250 into 5, that is 1250, into this 1.75 divided by 18, and this whole multiplied by 10 raised to minus 5. 1250 into 1.75 upon 18, total multiplied by 10 raised to minus 5. So this is log of 1250 plus log of 1.75 minus log of 18. Substituting these values, we get this log is 3.0969 plus this log is characteristic is 0, log of 17.5 is 2430 minus characteristic is here 1, log 18 is 1.2553. Addition of this first two is 3.3399 minus 1.2553. Subtraction of these two is 2.0846, and we find antilog of this. Antilog, that antilog is 1215, but here there is 2, so 121.5, and already there is 10 raised to minus 5. This is the EMF. By rearranging the term, we write this as 1.215 into 10 raised to minus 3 volt. 1.215 into 10 raised to minus 3 volt, but 10 raised to minus 3 volt is 1 millivolt, so it is 1.215 millivolt. This is our required answer. Now see next numerical based on the electromagnetic induction. The mutual inductance M of two coils mutual inductance M of two coils is 1.5 Henry. The self inductance of coils are, self inductance of the two coils are, L1 is 5 Henry and L2 is 4 Henry. These are the self inductance. Find the coefficient of coupling between the coils. See here, M is given, that is 1.5 Henry, L1 is 5 Henry, L2 is 4 Henry, and we have to find coefficient of coupling. We denote it by K. Very simple formula. We know coefficient of coupling K is M upon under root of L1 L2. M is 1.5 under root of 5 into 4. This square root of 4 is 2, so 1.5 upon 2 into under root of 5. 1.5 upon 2 is 0.75, and by square root table that root 5 is 2.236. We solve this much part, that is log of 0.75 minus log of 2.236. Here characteristic is bar 1, and that log is 8751 minus, here characteristic is 0 and that logarithm is 3495. Subtraction of these two log, subtraction is bar 1.5256. We find the antilog of this number, and antilog of this number is 3355. Bar 1, so 0 point, or we write this as 33.55 upon 100. 33.55 upon 100. So coefficient of coupling is, in percentage, it is 33.55%. 33.55%. Then we see two more numericals. Here, these numericals are also very simple. A toroidal ring made from a bar, a toroidal ring made from a bar of length 1 meter and diameter 1 centimeter. Length L 1 meter and diameter, that is D, 1 centimeter. It's bent into circle. This ring is bent into circle. It is wound tightly with 100 turns per centimeter. It is wound tightly with 100 turns per cm. If the permeability of bar is equal to that of free space, that is mu 0. Calculate magnetic field inside the bar. Magnetic field, that is B, inside the bar. When current I circulating through the turns, is 100 ampere. Full stop. Also calculate, we have to also calculate the another value. Self induction of coil. Self inductance, that is L of coil. See here, toroidal ring, its length and diameter are given. Length is 1 meter, given data. L is 1 meter, then diameter is given, that is 1 cm. In meter, this is 10 raised to minus 2 meter. Length and diameter are given. Then number of turns, 100 turns per cm. N is small n, that is 100 turns per centimeter. This is nothing but 100 turns. Centimeter means 10 raised to minus 2 meter. This is 100. When this is shifted to numerator, that will be also becomes 10 raised to 2. So 10,000 turns per cm. When this is shifted to numerator, this small n is 10,000 turns per meter. Turns per centimeter, we convert it into turns per meter, and then I is 100 ampere. I is also given, that is 100 ampere. Now what we have to find? We have to find the B. And also calculate the self inductance L. We have to find the value of B and L. Now we know B is mu0 Ni. Magnetic induction B is mu0 Ni. We know value of B mu0 is 4 pi into 10 raised to minus 7. That N is 10,000, that is the 10 raised to 4. 10 raised to 4, 10,000 into I is 100, that is 10 raised to 2. So this is 4 into 3.142 into 10 raised to minus 1 plus 6 minus 7, that is minus 1, and this 4 into 3.142 is 1256. That is 12.56 into 10 raised to minus 1, or it is 1.256, and as this is B, its unit is Tesla or Weber per meter square. Our first answer is 1.256 Tesla. Now firstly we find the area of cross section to find the L. To find L, firstly we find the area of cross section, and it is pi d square upon 4. Pi d is 10 raised to minus 2, its square divided by 4, that is 3.142 upon 4 into 10 raised to minus 4, 10 raised to minus 4, and this is 0.7855 multiplied by 10 raised to minus 4 meter square. This is the area of cross section. Now we find the inductance L, that is N phi upon I. N into phi, very simple formula, N phi upon I, but capital N is N into L, phi is BA, NL upon BA into I, small n we know it is 10 raised to 4, L is 1, B is 1.256, area is 0.7855 multiplied by 10 raised to minus 4 divided by I, that is 100, it means it is 10 raised to 2, 100, that is 10 raised to 2. By solving this, we solve that total answer, we get L is equal to, see here, that L is 1.256 multiplied by 0.7855, this 10 raised to 4, 10 raised to minus 4, that becomes 10 raised to 0, and that is 1, and that 10 raised to 2, when shifted to numerator, it becomes 10 raised to minus 2. We simply solve this part, that is log of 1.256 plus log of 0.7855, this is 0. This much log is 0.0990 plus bar 1 point, that log is 8952. Addition of these two log is bar 1.9944, and we find the anti-log, that is 0.9868. But this is already multiplied by 10 raised to minus 2, that is multiplied by 10 raised to minus 2, or we write it as 9.868 into 10 raised to minus 3 Henry. 9.868 into 10 raised to minus 3 Henry, but 10 raised to minus 3 Henry is 1 millihenry. It means this answer is 9.868 millihenry, or it is approximately 10 Henry. In our textbook, answer is given 10 Henry. You may write it as 9.868 millihenry, or it is 10 Henry. Then we see last one numerical on this chapter. If you know the theory part, you can easily write the formula by reading the data, substitute the values, and you can easily find the answer. A long solenoid of length L cross sectional area A and having N turns and having N1 turns, capital N1. These N1 turns are for the primary coil. Has small coil of N2 turns This is nothing but secondary coil. Wound about its center. Determine mutual inductance of two coils. We have to find the mutual inductance between the coils. Now here see the problem. Solenoid is given, its length is L, cross sectional area is A, number of turns of primary are N1, number of turns of secondary are N2. If current through the first coil is suppose I1, and due to current I1, we write this as due to current I1 in the first coil, two coils are there. Due to current I1, the magnetic field in coil 1 is, the magnetic field in coil 1, we call it as B1. Suppose magnetic field in the first coil is B1, and that is mu 0 N1 I1. Magnetic field in the first coil is mu 0 N1 I1. This small n is the number of turns, and hence we write it as mu 0 number of turns per unit length, mu 0 N1 upon L into I1. Small n1 is the number of turns per unit length. So for the first coil, number of turns N1. So this is capital N1 upon L, mu 0 N1 upon L into I1. This is the field in coil 1. Due to this field, flux linkage in coil 2. Due to this field, flux linkage in coil 2, and we denote it by phi 2, and that is N2. Flux linkage in coil 2 is phi 2, and that phi 2 is N2 phi 1. We know this formula. N2 into phi 1. But this phi 1 is B1 into A. So this phi 2 is B1A, or this is N2. B1 we know mu 0 N1 I1 upon L, or this phi 2 is mu 0 N1 N2 I1 upon L. Phi 2 is mu 0 N1 N2 I1 upon L into A, that A is here. This is B1 and into A, mu 0 N1 N2 I1 A upon L. But phi 2 is M into I1. Phi 2 is M into I1, and therefore M is phi 2 upon I1. See here, this is phi 2. So we write next step as like this. M is phi 2 is mu 0 N1 N2 I1 A upon L divided by I1. This I1 get cancelled and we get that M as value of M as mutual inductance is mu 0 N1 N2 A divided by L, N1 N2 A upon L. So this is about the numericals. Now we stop here. Thank you.